The board is used to hold the end of a four-way lug wrench in position. If a torque of 30 Newton meters about the x-axis is required to tighten the nut, determine the required magnitude of the force F that the man's foot must apply on the end of the wrench in order to turn it. Force F lies in a vertical plane. Okay, so force F is in the vertical plane. It's in the plane of this. It's like in the ZY plane, or not in the ZY plane. It's parallel to the ZY plane. It has no component in the X direction is what they're saying. So we want to find the torque is about the X-axis. So what's the moment of this force about the X-axis? We could do a vector formulation, but this is simple enough where we can do the scalar analysis. So we could either find this distance here, the perpendicular distance from the axis to the force, or we could just say the force has a vertical component and a horizontal component. This component intersects the x-axis, so let's just find the moment of this component about the x-axis. So that is F sine of 60 times this 0.250 meters. Okay, so F sine of 60 times 0.250 meters, and we need this to be equal to 30 Newton meters. Now let's just solve for F. $138.6 newtons. And so again, the moment of a force about an axis, if you're just looking at it from the scalar standpoint, right, we're not going to turn this into vectors and do the whole vector formulation. It's the perpendicular distance from the force line of action to the axis. It's the same thing with the vector formulation, but the cross product takes care of all that for you. If you're doing it manually, then if we would have found this distance here from the x-axis to the force, that's perpendicular to the line of action of the force, this d, we could have just multiplied force times distance, and we would have gotten the same result. If we were going to do it as a vector formulation, we would have represented this force as a vector, so it would just have a j hat and a k hat component. We would have represented the axis as a unit vector, so that would just be I hat. Then we would have found a position vector from the x-axis to any point along the line of action of the force. So that would have probably been easiest. Maybe we could extend the line of action out here, and then we could find just like a k hat r vector. That might be the simplest. Or a pure j hat vector, or we could use a vector like this. Any vector from the x-axis, anywhere on the x-axis to the line of action of the force. So that would be our r. This would be like an r. Then we would do r cross F, dot that with I. Then we have the magnitude of the moment of the force. Well, we would have to set that equal to 30, and then solve for the unknown force that way. Because once we do r cross F and once we dot that with I hat, that represents the magnitude of the moment of the force, which would be, we'd set that equal to this.